thing that I always forget to start record this thing. Yeah. So if I forget later on other time, please remind me to start the recording. And sometimes it shows that it's a bad network, but I hope that you can hear me clearly anyway. So I will not always keep the video open because some of you may have trouble accessing the video and the session together, because if there is video, it takes it becomes heavier anyway. So I think I will keep the video for some time, and then not every day. All right, so let me go into that unit outline. And before that, may I ask that, okay, some out of these 24, 23 students we are having now this semester, many of your names are very familiar to me, because I think I met you in during this chemistry foundation, right? So you know me, have seen me before, and it is good to find old friends again. All right, so if any question, any inquiries regarding this unit, regarding this content, regarding this the materials that we will be learning this semester, please email me. All right, but when you email me, our prior communication will be through the emails. So when you email me, please allow me 24 hours at least to get you back. And if I forget to reply you within 24 hours to 48 hours, email me again. It is not that I did not reply you on purpose, but it is like I forgot, or I was caught up in other things. Okay, so this is our unit outline actually can be found from this canvas, and I have uploaded outline in the canvas. Okay, let me go to the canvas then. It is better that I can show you from the canvas where we can find what. Where is it? Okay. Sometimes it is hard to see that you are sending some message, so it will be. There is a lot of disturbance. Can you, my voice is not clear. You cannot hear me clearly, is it? I want to make it the network is not very strong here, even though I am at office. I don't know. Okay. So, Muhammad Taha, is it clear to you now? The others said okay, so probably you can check your internet. Yeah. Please check the internet. If it is any problem, probably because others say it is fine. So probably there is no problem from my end. Okay, what I am going to show, anyway, the recording will be available, and I'm actually coming one by one where you can find the recording, what is the things, everything. Okay. So the thing is, all the announcement, as you see, some who are already, not new in to Swinburne who are already familiar with this Canvas thing. So you know where to find this announcement and all those things. And most, all the communication for this unit will be through this Canvas. Okay, we will contact you through this Canvas, and through the announcement you will be updated about any event or anything that will be changed, whatever there will be any update will be communicated to you through this Canvas. And from announcement, okay, and then in the syllabus section here, you will see the unit outline. So if you click on it, you will get a PDF version of the unit outline. I will go to the unit outline in a bit, but let me go through this Canvas section first. So in the discussion, we haven't started any discussion now, but later when we'll assign the assignment, you will have an assignment. Those who have already have a look at the unit outline, you know that there will be an assignment later on this semester. And that time we will start to do some group discussion. All right, we'll try to do some group discussion. And then if you can see the previous discussion, you can go and have a look. There was some discussion topic I posted, and there was some engaging reply from students as well there from the previous semester. All right. And grade is for me, and you will see your grade. If you click on this grade, you will see yours. But if I click on it, I will see everyone's grade. For here, I show you that what I see. If I see the grade, okay, it is not being graded yet. That's why there is no assignment has started. That's why there's no grade. But I will see the grade. The student, give the grades to the students. And for this module, you will see every week there will be the modules. Okay, it will be available. I will make it open. Probably you cannot see it now because I haven't make it open or published to a student yet. But when I publish it, you will see the lab menu. For the week 1, okay, the lecture and then the tutorial, the lab manuals, and the lab safety assessment form. So this is one important thing is you have to, this lab safety, you will find assignment here, not assignment actually, a lab safety manual. What you should do in the lab and what you shouldn't do in the lab, or what is not allowed or permissible in the lab, you can find from the lab manual. I will talk a bit about it during the next week lab session that will be on Monday, 2 p.m., right? 2 p.m. I will talk a bit about it. And then you will have to submit the lab safety acknowledgement form. Everyone should download it and then sign it digitally. Okay, you can sign digitally, no problem. And then you go back to this module, and then you will see that lab safety form submission. So you should submit here. You will see that you will have to submit 12 March, so that you have to submit here by 12 March. And as a PDF document, you should upload after you sign it. And this is for lab safety assessment form, and it is very important. If anybody submit this lab safety assessment form, he or she will be barred from entering the lab. And since there will be no lab for first 1 week, or this week and next week, first lab online. So if you do not submit this lab safety assessment form, then we will not evaluate your paper, your lab report. So it is very important. Okay. And then safety practices, you can also see in that. I will talk about it during the lab session later on. So this is it. Every week it will be open to you, and you will see the activities the assessment, the lecture material, the tutorial material under this module here. And also, another thing is every assessment or assignment or test, it will be posted here during that week. Okay, let's say that we'll have another one test during the week 6. I'm saying week 6 or week 5, whatever. Then the test question will be available under that module, under that week module, so that during that time, only during the exam time, you can access that test question. So this is it for the lab safety. And okay, now another thing I forgot to mention in the home actually. So this is our unique structure that I'll talk about it in the when I discuss the what do you call it, unit outline. So this is me, I'm Bazlul. I'll be convening for lecture and tutorial. This is Miss Megan. She will be assisting us for the lab session. So if there is a face-to-face lab, she will be there in the lab, and you can ask her for help or questions. So this is my email. You can email me if you need to, or if you need to inquire anything or ask anything, you can email me anytime, no problem. Anytime you can email me, all right? But if you are allowed to come to the campus, then you can meet me. If you want to see me, you can meet me during this time, okay? During this time. And for Miss Megan, you can email her to this email address, and you can, if you want to see her in person, let's set an appointment by emailing her. I'm not sure when she is free. And this is the link that you can this MS Teams links that you just click on it and you can get to that link. Okay, let me go to this unit outline now. Okay. Unit outline is, where is it? Okay, here. Okay, so this is our unit outline for this semester since 2021. And there will be assignment 10%. It is a group work. Okay, it will be a group work, online quizzes that individual, everyone will have to take the quizzes, laboratory, that will be a group work as well, and test, that means normal time it will be final exam, so it will be individual as well. So this is two individual assessment and two group assessment. And our unit learning outcomes is we will know about the atoms, more about it, and the acid and base, the calculation and the mole concept of it, stoichiometry, gas laws, and everything, all those things that are included in it. And we will see the qualitative and quantitative of chemical reactions. We have, those who are from the foundation, you will see some similarities, not some actually, quite much similarities in the first few weeks, like first 3-4 weeks, you will see quite much similarities with that foundation chemistry, because it's all about chemistry. But during this time, we will be go much deeper, all right? So you are not a foundation student, you are an engineer now, almost in the making. So you will have to be responsible about much more sophisticated and then calculations things. And you have to articulate the concept of chemistry and chemical knowledge to calculation, and then the outcomes of it. So we will be studying much deeper in chemistry and chemical things. Okay, so the pH, acid and weak acid base and all those things, these are very much similar, or you will feel much more similarities with that we have studied in foundation. But later on, these things we will also want you to refresh your memories, because this thing will be needed to understand these few things. And this is when we go after week 5 or week 6, you will be there will be total new things. All right. So if you do not understand, or if you have lack of understanding in these things, that will be much more difficult to understand. So I will request you to pay much attention for our, if you even see that it is similar what you have learned, let's again pay attention, try to do these practices and refresh your memories about these processes, knowledges, so that we understand much about this organic process of organic chemistry. So now you understand that for this unit, we will have inorganic chemistry that will be for first few weeks, like first 5 weeks, and after 6 or after sem break, we will start for organic chemistry, and those organic chemistry will be needed to understand those organic chemistry. First few 5 weeks will be much important for you to pay attention to. Okay, so all those things that is taught into you, and you will be learned about this. We aim to equip you with these knowledges, so that we hope that you will learn this thing. All right, so this is my office telephone, so that you can call me during the office hour, and this is my email, so you can email me during this, anytime. You can email me at any time, no problem. And this is Miss Megan's email, and I do not know her office phone. All right, so this is our of teaching, that what we should do, that teaching will be 3 hours per week and all 12 weeks of teaching. Tutorials will be 2 hours per week, all 12 hours, because first week there will be no tutorial, so that is 12 weeks of tutorial work. And for laboratory work, that will be every alternative week. So we will have 6 tasks or experiments to do. So we will have 12 weeks to conduct all those 6 lab works. So it will be alternative weeks. Like if we this week, first week, there will be no lab, so obviously it will be second week. So there will be, in second week there will be 1 lab, but third week there will be no lab, and then it will be again on fourth week. So in this way it will go. And for your own learning, independent learning, that is called, you should try to understand, learn, or read more about it. So this 72 hours is kept for your own learning. And what we do for the first lecture, atomic structure, this is our aim to study this. But before this, we will talk much about the significant figures, okay? So these significant figures is important. I'll go into it soon. And then after that, the mole concept and all those things, you can find from here that what we expect, or what topics will be discussed during this week. All right, another thing is online quizzes. There will be online quiz every alternative week. So we'll start on week 3, all right? We'll start on week 3. In week 3, the online quiz. Here, everybody, all of you should go for online. The quiz will be open for a certain time, for 2 to 3 days. Okay, maybe 2 days, the quiz will be open, and then everyone has to log in through your account, and then you have to take the quiz. Okay, you cannot, somebody else cannot do it for you, so you have to do by yourself. And this quiz will be there will be 5 quizzes, so it will not be for every week, right? So you will see, the previous topic has been discussed, all those questions from those topic will come up in this online quizzes. Okay, and section of lab report. If even we do this face to face, you have to submit the lab report through this online Canvas link. Okay, there will be a link open for you to submit, so that you can submit the lab report there. And yeah, so this is it. This is the tentative date of final exam or assignment or anything. It is not the date is not the content, the topic, the assessment types, all are confirmed, but on not the date. The date can be changed, and if it is, when it is, the date will be announced through Canvas. So of course you will know it from the Canvas. So we know that it will be on week, let's say the final test will be week 10, but we do not know a date the test will be. I will find out the best date for you, and then I will announce it. Of course, 2 weeks before, I will before the test, I will announce it on Canvas, so that you will be prepared. At least 2 weeks before, I will announce the date for the test. For assignment, one assignment will be assigned to you guys, and that will be, where is it? Assignment submission. So week 8 will be assignment submission, and week 4, I think I will assign the assignment. It is not written here, but anyway, week 4, I will assign the assignment to you, and it will be assignment on the topics related to these all three. It will be submitted on week 8. So the assignment topic will be related to all these 7 weeks of that we study. All right. So this assignment will be related to those topics that we have learned so far for these 7 weeks. Okay. And what else? Oh, the thing is, you will have to form the groups for lab and for assignment. And you have the liberty to form the groups by, you are not a foundation student anymore, you can take your responsibility, that we know, and I hope that many of you know each other, if not all. So you can form your own group. Okay, for lab you should form 4 per group. No, so 3 per group. All right, for lab 3-person 1 group. For assignment 4-person 1 group. I will post this. Actually, I have this all these things written up, and I will post it on Canvas, so by tomorrow. So you will have to find your partner for lab and for assignment. For lab, there is 3-person per group. For assignment, there will be 4-person per group. But you cannot have the same all 3-person in that lab for the assignment group. You have to mix and match, you have mingle with others. So if there are 3-person in a lab and all these 3-person plus any 1-person in the assignment group, it is not accepted. You can have maximum of 2-person in that assignment group from the lab group. You have to, you have to find a way that how you can mix and match. This is to make sure that you cooperate with diverse group, diverse people that your skill, interpersonal skill grow. This is aim for this mix and match. Okay, so this is it. And so the weighting for this test and assignment and online quizzes are given here. All right, all these things are given here, and where and when it will be, the tentative date for this or week is given as well. For this unit, you have to achieve at least 50% to pass for this, okay, overall, and at least 40% in the final assessment. That means it should get at least 40% in this 25%, all right, to make this 25% and this 20%, sorry, both. Okay, you should get 40% of this 5% marks. So you have to get 40% out of these 20 marks, or 45%, 40% out of this 20% marks, so that you will be considered at least to get the minimum one to pass. If you do not get 40% out of these two, final assessment 1 and 2, then it will be maximum 45% you will be given, and the student will consider not pass. Okay. Submission requirements. Every alternative week, as you know, that you have to submit the lab report, right, through the Canvas link. If you, by time the date, the submission link will be open for like 1 week or 3-4 days, it will be open, and there will be a due date. So, and you will know that for a long time, for almost, when the experiment is done, you will already automatically know that the submission is by next week, before the next lab starts. All right, so the submission will be before the next lab starts. If you do not submit, that your marks will be deducted. All right, so 10% marks will be deducted for every day you delay. Like 1 day you delay for this lab assessment, 10% marks will be deducted from that lab report. And for 1 day, if 2 days you delay, 20% mark will be deducted. 3 days you delay, will be 30% mark deducted. If you delay for 5 working days, then no marks will be given to that lab report anymore. Okay, please understand this. Okay, and referencing for lab report, talk about it during the lab report. But we'll be following Swin-Harvard referencing system. From here, you can find the reference style, how you reference, and the required books. The 2 books will be followed for this. Now is Raymond Chan for Raymond Chan 2016 Chemistry 10th edition. You will find from the Swinburne library, and then for organic chemistry, we will find Robert J. Oakley. You find this from Swinburne website or Swinburne library website as well. But I will add another book for organic chemistry. It will be number 3, and that book I will only make it available when we start for this organic chemistry, so that I will I announce it through the Canvas. Okay, so this is basically it for our unit outline, do's and don'ts, and what to expect from here. And do you have any question now? Hello, anyone has any question? Oh, good to see that you are following. Okay, thank you for your response. So now I will talk a bit about what does it take. All right, wait a bit. Okay. Most of the time, students will be curious that how can I get a good grade? How can I get a HD or something like that? All right. So, okay. So, what to do and how should I study or what should I follow or how should I do these things all through the semester that I can get a good grade? Well, first and foremost, the thing is there is nothing uh, nothing beats of studying. Okay, first and foremost, you have to be careful, you have to be serious, and you have to study. That is the only and study and fail-proof strategy. You have to study. That is the thing. But how do we study things? First of all, let us go through these unit aims that we provide introduction and basic concept of chemistry, and then the understanding of structure of element and how to determine the interaction between them, and if we do the interaction, what happens, how the next thing or how this new things occurs by this interaction. It is very easy that we, for the chemical process or chemistry, we just mix them together, one thing, and then there will be a third thing, right? It is not that simple. Sometimes even you, if even these two A and B produces C, not all the same condition. We have to understand what is the condition and why this condition is needed. So that is things that we need to determine at what condition should you be mixed, this A and B, to produce C. And if this C is produced, whether this C is workable, it is stable, or it is gonna just vanish up after being produced. So all those things we can find from the chemical knowledge. But, and of course, the thing is, what do you call it? For this, we need to understand the basic properties of chemical and chemical processes, chemical processes. So we will. That's why we'll read or study the various reactions of elements and compounds that will undergo in those type of reactions. And when we call about, talk about the reactions, different reactions that will producing another compound, you cannot just add any amount. You have to add to a certain amount, and that amount based on the calculation. What calculation? That is the ratio of their moles. And the qualitative. If even you add that same number of moles or same quantity, the reaction may not occur because the quality of that compounds are not good. So that the qualitative and quantitative measurements you have to understand. We have to understand that for the reaction. And of course, in the lab, we will try provide you with the basic knowledge and how to handle the chemicals in the chemistry lab, and what are the hazards of the chemical to human and environments. All right. So this is the content that we have already outlined in the plan. A little bit detail of it is the acid and base and hydrocarbons and aromatic hydrocarbons. It will be discussed later during the organic chemistry. halides and alcohol. What are halides? What are alcohol? What are the reaction? How do they form? How do they do reactions? And sometimes why they do not do the reactions? All those things we will be discussing it. All right. So to pass this unit is attendance to the lecture and practical session are compulsory. So your attendance will be taken automatically. All right, and every 3 weeks, every 3 consecutive class actually. So every 2 weeks, your attendance will be sent to the Student Central. And if you are not attending without any valid reason means a medical certificate or any other urgent matter, then you will be if you have those type of things, then you can ask me or you can send an email to attend or you did not attend because of this problem, so that I will not send that report. I am not doing it because I'm bad, because this is the requirements from the Student Central. It's nothing from my side. Okay. And okay, for the tutorial class, there will be no replacement class. Okay, only one session. And since the sessions will be conducted through this online, and it will be recorded, so there will be no replacement, and you can later watch the recording version. Okay, so for the assessment, you should attain at least 50%. That already we have discussed it. And then if you attain less than 40% in the final, then you will not get, you will not pass. You will be given a 45% altogether, and then you will be considered not pass for. Okay, and penalty, there will be penalty for late submission and plagiarism. So what is plagiarism? Late submission penalty I already have discussed, right? Late submission penalty I already discussed that every day you are losing 10% of the marks for the report. And same thing goes for the assignment as well. When you submit in the 8th week, the assignment, if you are 1 day late, then it will be 10% mark deduction. And every day, like 1 day 10%, second day, after 2 days you submit 20%, you are losing. After 3 days you are submitting 30%, you are losing. Not you, the whole group, everyone will lose the same mark. So this is for the for the plagiarism is that there is a new, whole thing is on the Swinburne library. What is plagiarism, how to avoid plagiarism, and what to not to do plagiarism are already there. But in brief, I tell you that if you are quoting, if you are taking someone else's work and you are writing as your own work and submitting as your assignment, without quoting them, without giving them the due respect or due attribute, then it will be plagiarism. So since your assignment has to submit through this Canvas will automatically check the plagiarism. This is what we did not do for foundation. Okay, those who are from foundation, please take note that you did not do it. I don't know whether you have done it for your first year, but for second year, for now, we will be, this is for Swinburne's strategy that we are particular about this plagiarism, and we do not condone any plagiarism behavior. So please take note. And then if your work is matching exactly with other works without you paying this their credit to them, it will be considered plagiarism, and then you will be also miss some marks. Okay, you will be missing marks for this. Okay, and what should you do is the student characteristic, those who get the high distinction or HD, that is more than 85% marks they will get. What are the difference between them to the distinction student, right? They are very much same, very much same. It's very hard to distinguish between those HD students who gets the HD and those who get the D. They're very much different. But the major thing, the very subtle thing is that they are they they process the content in their head, in their mind. They will always intelligently ask themselves or aware themselves about the idea or the information they will learn, solve another problem, okay? To solve, constantly they solve, or to relate to a problem to solve them, okay? That is the difference between them. They're very similar to them, all the good students. And those who are credit, they will all, almost very similar to that distinction student, but they will only focus on how to do the problems and not interested the underlying ideas of the problem occurs, and just to minimize the problem through the knowledge they have gained. So not just, the credit student, they will only try to, okay, this is a problem, there's a mathematical, I just want to solve it. They know how to solve it, they are very good, they can solve it, but they will not relate that problem to other problem, okay? That we have solved this problem in this way, I can solve this type of problem, whatever, or if it is a little bit different from this problem, they will try by themselves that to solve the other type of problem. So this is the difference between the credit and distinction student. And for those just get a minimum pass or 50%, just somehow want to pass, they will they are not, they will just submit, okay, I have to submit by tomorrow, just submit whatever. I have seen some student, okay, some report, they don't do anything, and paste the whole assessment work that has been given to them with a little bit, like 4 or 5 lines of their own, and then this is, we understand, when we look at it, we understand that they just don't submit something, they really didn't try, okay, at last minute, and they will always say, I busy, I couldn't submit, extend the date. So this is not serious thing, okay, the lack of seriousness. But one thing I want to point out here, that all those 3 types or 4 types of students are, everyone are same, okay? When we go to the class as a teacher, we see your eyes, we understand, but now I cannot see, of course, because I don't know what you are looking at me, or you are listening at me, or doing something else, who knows. But when we go to class, I look at your eyes and I see that everyone, to some 99%, everyone is same. Only the difference are made, somebody is serious when somebody is not serious, right? So that is the only difference that makes. I will ask you to be serious from the very beginning, okay? Pay attention to what is, the task is given to you, and complete it within the stipulated time that is given to you, all right? So that is the difference between them. So the suggestions that you should do is read books. That is only one rule for success, okay? And then you try to make the mind you study when you are, not for only chemistry class, for other units that you are taking, I don't know how 3 or 4 units you are taking this semester, you learn the things, you make the map in your head or in your mind, try to relate those maps to different what do you call it, ideas, link it, so that you will know that it will help your understanding better, right? It will help you study chemistry now, you understand one property of a acute, relate it to the thermodynamics or to the whatever other units you are taking, the environment or anything. It will help you more. You ask question, you work in a group. The group work is the one of the main success actually, if you know how to take benefit out of it. To discuss, initiate Okay, don't wait for others to initiate that, come and ask you that, oh, have you done this? Did you know? No, no, no. You ask to the group member, not only your group member, you can ask other students, other friends as well. You initiate that thing that I have that idea, I understand, I don't understand, or how, I mean, this is a funny idea, or whatever. Okay, try to relate it or bring it up to the group discussion, and that will make your understanding of that idea better. Okay, teach others. If you know something, or if you do not know something 100%, of course we do not know anything 100%, but if you learn something or if you have understand something, go and tell to your friends or your other siblings. So try to give a presentation, a short presentation, maybe 1 minute, 2 minute presentation, so that you will understand. When we teach other, we understand, we learn more, believe me. You try, I mean, you do it yourself, you will know that it is true. Deep learning and surface learning. So the ideas, those who are deep learner, they will criticize their ideas. They will criticize the content that they are learning. They will link it to the other matters, other subject, other topics, and that is how they will learn more, much deeper. Okay, and those who are surface learner, they will just they will just learn. What do you call it? Listen to something, and that will be on their mind, on the surface of their mind. It is not going into it. They are not questioning this. They are not analyzing this in head. All right. So it does not really have a chance to go deeper into their understanding process. And this is the difference between surface learner and deep learner. So the positive, being determined to do well and mentally engaging the academic work, those who what deep learners do. And for the surface learner, they do not do the determination. Just, okay, I'll do it somehow. Okay, if I not today or tomorrow, I'll do it. This is motivation that. Okay, so this is the difference between the deep learner and surface learners. Okay, so this is what I wanted to share with you about this, what to do in the, to get a good grade or to understand, not only for chemistry, for any other units that you are taking or you will be taking later for this semester. Okay, so I did the presentation. Did you see? Okay. All right. Now, do you have any question? Yeah. So far, any question? Anything? It's not necessarily have to be from this chemistry or anything. Any other thing? Okay. So I guess you don't have any question now. So what I'll do is I will go. I will not. We have 2 hours, right? Do we need lab course for lab session? Yes, Jonathan. Yes, we need that. Oh, thank you for bringing this up. So because of this, I mean, previously what we do, we used to provide the lab coat. We used to provide the lab coat for students. But now, this pandemic time, we will not give the lab coat to the students. So you have to bring your own lab coat, all right? You have to bring your own lab coat, and then if you need to buy this lab coat, you can buy from the online shopping probably, or you can contact Yan Ing or Doris. Let me find their email. Doris and I cannot. Okay, this is Yan Eng, and another one is Doris, Miss Doris. I'll send you. Okay, these two people are responsible for our lab. So if you need the lab coat, please email to them, or otherwise you can go for this online shopping, online platform from Shopee or from Lazada, whatever. So anyway, I mean, either way is okay. If you can email them and see how long they will take. But I think online shopping is easier for you guys. So you have to have your own lab coat, and all of you actually, I mean, later on you will be notified when, if we go for face-to-face lab session, we will be notified, because all 24 students are not allowed to come at the lab at the same time. So you will be divided into two sections, and yeah. So I will let you know who will have a lab session on what day. Okay. So these are the two things, and what else? So for sir, will there be online labs? Yeah, whatever. If even there is a face-to-face lab session, there will be an online lab session as well. Everything, there will be an online session. So you know that how busy we will be. We have to do the same thing over and over again, and it is very not a thing that we would love to do, but no problem. We will do for you. No problem. There will be online session for any tutorial or lab, even we go for face-to-face. So don't worry, those who cannot, don't worry. No problem, you're welcome. Okay, so you have any other question? If no question, then I would like to go to our week 1 lecture session. Oh no, why it is opening here? I don't want it to be here. Oh, I understand. Okay, so I hope that you can see the PowerPoint now, and the title for this PowerPoint is Matter, in fact, and the atoms, molecules, ions, and the calculation that involves them. So we will start today about this, but first of all, we will start with the uncertainty, scientific figures and uncertainty, all those things. Starting with structure of atoms and their the numerical problem to solve those things, and electronic configuration of atom, including the SPD notations, and physical and chemical properties of the elements based on their appearance in periodic table. We'll see all those things, but the thing is, first of all, you can see that there is quite many slides here. I will go through a very fast of first 50 slides very fast, because these are the scientific figures, and since you are the engineers almost halfway, so you cannot skip this scientific figures and then how to write the scientific figures. I'm not sure whether you have learned already. If even you have learned, then it will be a nice refreshing of your knowledge, and how do we calculate with the scientific figures and the error or the tolerances of it, the significant figures of it, and all those things. So I will start in around 3 minutes, 4 minutes. Let me go and make a cup of tea. My throat is almost dry. So I'll start after 5 minutes, okay? Hello, I'm back. You're with me, yeah? So now we'll start about uh, our first topic of the lecture for the first week. That will be, I hope that you can see, yes, I hope that you can see, that is the atoms, molecules, ions, and calculations, and their calculations. So the learning objective for is, okay, let me go to the full screen mode and, okay. So there's a pointer. Scientific figures are significant figures in expression of the results and uncertainty of the measurement. Why it is important? Because this is one of the most important thing when we do calculation and when we report the measurements or results in our report. This is very important, and later on, after we are done, this will take some time, and then we'll see the structure of atoms, and probably we'll see tomorrow. Solve numerical problems related to atomic mass and moles and molarities. Some of these are very common to you, or you are very familiar with that. Then we'll see the electronic configurations of electrons and ions with SPD notation. So far, we have seen that electrons are outside the nucleus and they round and rotate around atoms, but at what, how, or at what course do they rotate? That will be discussed or explained as SPD notation that we will discuss later on. And of course, we will see that different type of oxo acids and bases and their chemical formulas, and what are their appearances on periodic table based on their position on the periodic table, what are the appearance and properties. So the periodic table will also be discussed. So many things we'll be discussing in this topic 1. And again, what is the need for chemistry? Although it's engineering chemistry for us, we'll be focusing more into the engineering usage of it. But chemistry as a whole is it's a very, very wide and big field. I mean, one of the main things actually. So to study to knowledge. So we don't need to talk much of, reiterate actually what the, but to relate to our 21st centuries, okay, what chemistry or chemical knowledge can do to our environment at this age, 21st century, we can find from this, a little bit overview of this from this of chemistry that is doing from this top slide. Chemistry is everywhere. It is health and medicine, no doubt. Medicine cannot do anything, or we cannot do any progress in health and medicine without the knowledge of chemistry, right? Environment and energy production. Nowadays, you know that we are going from fuel energy, that is what is called petroleum energy, that is what does it call? Petroleum is non-renewable. Okay, so it's non-renewable to renewable, and nowadays the lithium battery, not nowadays, that this lithium, now there are so many advancement has been made already on the lithium batteries, the lithium, titanium, and also so much research is going on this battery, and you have to have a good chemistry, sound chemistry knowledge to study or to do research in that field, materials and technology. You all have learned about the nanomaterials, right? So if we cannot do much progress without the knowledge of chemistry in these material processes and the technology. And food and agriculture, of course, food and agriculture. We have to have a good and sound knowledge of chemistry to do some advancement or produce more crops to alleviate the poverty and the hunger. We have to produce more food, and to produce more food we have to do pest control, and we have to come up with the best solution for the fertilizer science. If we do not have the knowledge of chemistry, we cannot do any advancement or development in those fields. So chemistry is, so by now I'm sure you are thinking, what can we do without chemistry? Basically nothing. In the morning we wake up and then we drink water, right? And then we go to our bathroom and then we brush our teeth, right? Come back and drink tea, coffee, and then come down or check the mobile phone, and then come down to drive your car or motorbike. Everything, every single step of all those things, chemistry is involved in a way. You cannot do away with it. Okay. So the chemistry is very important, and I don't think that I need to talk much about it. Everyone knows it. But just to point out where is the niche for this chemistry that you should learn, and you should learn by, I mean, you should pay attention to. I mean, you be serious about it. Okay. We do all chemistry and chemical development. There are two things, that is qualitative and quantitative observations of those applications of chemistry. So what is the qualitative application? That qualitative is everything that we can feel, all right? Everything that we can feel, that we can see, hear, smell, taste, all those things, touch, and through our skin by touching. So those are the things that we cannot quantify. Like you eat a cake, can you tell that it is 10 sweetness on a scale or 5 sweetness? We say that, okay, it's very sweet or it's not sweet. It's very tasty or it's not tasty, right? We cannot quantify. So this is a qualitative observation. We need to understand the qualitative observation and quantitative observation. For the another thing is the evidence of chemical reaction includes evolution of gas, right, and the color changes of this, formation of precipitate. All these are qualitative observation, and for quantitative observations are the measurement that we can measure. We can put it on the scale. There is a type of measuring tool that we can measure 5 liters, 10 degrees, 1 kilometer, whatever, right? 10 inches. So those everything are quantitative, that you can measure it. The temperature, if we put our hand in the water, we can feel that it is hot or cold, but you cannot tell at how much hot or how much cold it is unless you are using a thermometer. So from the qualitative observation, it will lead to quantitative observation, to a more precise characteristic of that, right? So this is the quality and quantity measurements are required. So for the qualitative measurement, when we do the measurement, right? Just now I was telling that 5 degrees centigrade, 10 inches, all right, or 5 kilogram, everything. So when I'm telling you that 5 and 10 and 20, but with all of this number, I was using another unit or another term, that is the inches or kilogram, or what else did I say? Degree centigrade. So these all are the unit, measurement unit. So any measurement, quantitative observation, that should have one measurement number and another unit. So we can say that a student is 6 feet tall, right? So the 6 feet tall, that means if I would tell you that, okay, the student is 6, I would not understand what does it mean by 6. It can be 6, what? 6 inch, 6, 6-year-old. He has $6. Yes. So if I say that 6 feet, then I would know that talking about the height of the student, all right, or 5 feet tall. I'm talking about the student height. But when I'm talking about the 5 feet height or 6 feet tall, right, I'm not sure, I'm not telling you exactly that this is 6 feet, and I'm not expecting it to be 6 feet as well. I'm not expecting it to be 6 feet as well. What I'm expecting is that, okay, it is 6 feet. I mean, if you challenge that friend that is telling you that he is 6 feet tall, you can challenge him that, are you sure that you are 6 feet? Then he will say, okay, I'm sure that I'm 6 feet. But if you say that, okay, I want to measure you, I mean, measure your height, then you will see that it's not exactly 6 feet. It may be 6.1, it may be 5.11 inch. So in that way, that is the 6 feet. But altogether, we say it's 6 feet, and we do not mind in that case, right? If we say it's 6 feet, because we round it all up. We round it up to 6, or round it down to 6 when it is 6.1. So this, why do we need to round it up or round it down? Because there is an uncertainty in the measurement. When we are using that scale to measure 6 feet or 20 degrees centigrade, or there is an uncertainty in all those measurements. Depends on how do you measure it, all right? One is how you measure it. Another one is what measurement you are using to measure it. It depends on both. But for the time being, we will focus on the tools that we are using to measure it. Like the uncertainty, it depends on many things. Like we are talking about 20 milliliter of water, and then somebody else is saying, okay, 0.0 milliliter, somebody else come and no, I measured it 20.00 milliliter and 20.000 milliliter, right? What are the difference between all these four? What is the difference between all these four, right? So it means this first one, it is a rounded figure. It is a sorry for that. It is a rounded figure, it's 20 milliliter, and we do not know the uncertainty lying in it. It can be 20 plus 1, 20 plus 5, plus 2 milliliter. But for this second, right, for this second one, we know that uncertainty is 20. It cannot be 21, right? It can be 21 here because 20, so maybe plus minus 1, maybe plus minus 2, who knows? But for this case, number 2, we cannot say it's 20 plus minus 1 or 2, because 20 point, there is a decimal one place after the decimal, so it can be 20 plus minus 0.1, right? It can be 0.1, because anything has to go through this decimal point, decimal place, all right? It has to be 0.9, only then it will be 21. After 0.9 it will be, so here it will be 0.1, it can be 0.2, it can be 0.09, until 0.9 only. I mean the scale or the range can be here. For this number 3, we see it's 20.00, right? 20.00. That means the uncertainty, we understand it cannot be, of course, 20, it cannot be 20.21, it cannot be 22, it cannot be 20.1 as well, right? It must be plus minus 0.01 to 0.09. Only on this scale it can be, because anything goes up to and added up here, it has to pass through this 0.00. Just like here, it was only one decimal place, it is 2. So, and the number 4 is even more, it has to pass through all these 3 decimal places. So number 4 is much more sensitive, much more precise. It is very much close to correct value, or 20, because here the decimal places is 3. So anything, the uncertainty or the tolerance of the measurement, it has to be 0.001 to 009. Okay, so it is very, very precise until 1 of thousands for this number 4. So this is the uncertainty. Now, can we just write that uncertainty? I measure something 20 inches, and then can I just write, okay, 20 inch, 20 plus 0.0000 inch. Can I just write in this way? Can I just write, if I use a scale and a ruler, a simple ruler, the table ruler that I use, and can I just write it? No, you cannot. It has to be, tolerance has to be specified on that ruler. This thing will be specified, the ruler that you are using, that it is to that length, it is accurate. All right. If it is not mentioned, you cannot say in this way. We'll come to that point, how to do and what to write and not. Okay, so the scientific notations and significant figures. Significant figures, all those things are the significant figures, that is the figures in the measurement that matters, that we should be considering it, right? Those are the significant figures. For this table, can you find the number of units here? How many types or different types of number of units are used here? Can you find? Okay, 1 is gram, 2, second is degree centigrade, third is the milliliter. So these 3 units are used here, right? And then how many significant figures are here for this degree centigrade? This is 3 significant figure, 25.0. Why we are considering 0 as a significant figure? We are coming next slide to describe why. But even though it is 0 after the decimal place, we need to consider it for significant figures. When there is a zero before this decimal. Okay, we are going there too. But for this here, we see it's 4 significant figures. Even though it is decimal after 2 figures after the decimal places, it is 4 significant. This is 5 significant figures. This is 5 as well. This is 5 as well. This is 4. This is 4. So all these are significant figures. Okay. So now, how do we find the decimal places? Graduation of this analog measuring device for this thermometer. And let's say we are measuring through an analog thermometer. How we record the number of decimal places? Small graduation by divided by 2, right? And that is how we will find the for the analog thermometer, the significant figures, the decimal places that we should be using. Now the number and scientific notation for scientific notations, or in our measurement we use a very huge number. Even it is a very small value, but the number can be very, very huge. All right, so that is why sometimes we need to use 10 powered values. Okay, 10 powered values. And in this way, this is one example, but it can be something like 0.000, many zeros, and after that there is a 5 or 6. Sometimes it is very important for us to study even so small number. Even we need to study that, because you know, science calculation, you do calculation with a very small and strange number as well, or it can be very, very big, like a 9-digit number, 10-digit number, very, very big, right? So this type of numbers are used, and always doing the subtraction and multiplication, division of this is a huge task. So what we do is we can just express it in a scientific notation like this, 10 powered, so that it is manageable. It is much manageable than this one. It looks so odd. I need to count how many. 1, 2, 3, 4. If it is like 7, I have to count 7 zeros in front or after. So this is a little tedious thing. But if we can express it in this way, 10 powered, so it is much easier to manage. And in this way, it is also good to, easier to do all those execute those type of operations on this number, or operations on this number. So in this case, we see that here is 4.31, and then 10 powered 4, and here is 3.9, but 10 powered 3, and we need to add these two up, right? We need to add these two up. How do we do it? When there is 10 powered 4 and 10 powered 3, how can we do this thing? Of course, if you do in the calculator, you will be very fast, but we need to understand the basic thing actually before using calculator. So for this, we have to bring these two power to unique power distribution, or power notation. Like both of them, we should express either on 10 powered 3 or 10 powered 4. For this case, if we express this both in 10 powered 4, this one is unchanged, and this one 3.9 power 10 power 3, 3.9 times 10 power 3. If we want to make 10 power 4, what we will do is we'll divide by another 10 here, right? So that we can take another 10 here, that will add up to this point. So in this case, it will be 10 powered 4, and in this case, it will be 0.93. So it is 0.39, 10 powered 4, and then this 10 powered 4 unchanged in the total value, but 4.31 and 0.39, I just need to add these two up, and we can do without even calculator to make this and do the calculation. Same thing goes for this multiplication as well. We need to find and do this same thing, the power thing, and only this thing, just we do not need to bother about the power differences. We have to add these two up, like 4 and here is 3, so it will be added up to 7, plus, and only these two things will be multiplied. so that the values comes here. And divisions also the same thing. For the division, we just need to do the subtraction for the power and the division for the main values. So we 4.31 by 3.9, but this power are only subtracted. So in this way we can find the number of scientific notations. Okay, so now the significant figures that we're talking about, what are the significant figures, how to calculate the significant figures, right? There are some rules for the significant figures, and then the significant figure here for the 5 digits, and it implies uncertainty for this is one of these whole decimal places. That means here there are 1, 2, 3, and 4 decimal places. After 4 or after this point, so this uncertainty is 0001. So there are 4. This 1 is the uncertainty for this. 0.0001 is the uncertainty here. But here there is no decimal places, right? There is no decimal places. There's no 0.0. So since there is no 0.0 here, what you do is the uncertainty will be 1 plus or minus 1. So this 15 value that we are talking, it is 15. It might not be 15, right? Maybe it is 14, or maybe it is 16. It may be 15, maybe 14, or also maybe 16. So this is the uncertainty. But when it is decimal place, so the significant figure is for plus minus 1. So this value is not exactly 25. It can be 24.9 or 25.1 as well. Of course, okay, but there is a possibility that it will be 24.9 to 25.1. This is the range. There is a possibility that this will be in this range. All right. So this is. And that is why we are considering this 0, even it is after the decimal place, is a significant figure, because this 0 is signifying, or it is telling, could be that it is not something that you can just throw. It is very important, and because it's telling us the range of the value can be this. If there was no 0, right? If there were no 0 here, like I don't know how to erase it from here, but if there were no 0 here, then what would be the value? It could be 24 to 26, just like a 15. It could be 24 to 26. So there will be a big changes in this value, right? So that is why we cannot throw this. It is a significant figure, and the rules for the significant figures are all non-zero number should be considered. All non-zero number should be considered for this significant figure calculation or counting. Sorry, not calculation, counting. And what we shouldn't count is zeros before non-zero digits. All right. If there is a 0, there are any 0 before the non-zero, we shouldn't count that one. It is not significant. Just like we say it's 25.0, there is a difference. Just remember this 25.0 is there are three significant figure, right? Three significant figure here, 25.0. But if it were 0.002, there would be only one significant figure, because the zeros between before the non-zero digits we do not count, either if it is after the decimal places or before the decimal. It is not counted. Just like zeros between the non-zero we should always count. Zeros between the non-zero we should always count as a significant figure, either without with or without the decimal places. What we shouldn't count is the trailing zeros, like this one, 400 or 2000 or 2 million, 2 billion, does not matter. These zeros that is will not be considered. So this, for this case, it is only one significant figure. These zeros are not significant. But if there were only a decimal place and then there is another zero, then it would be counted. So it will be 1, 2, 3, 4, and 5 figures. In that case, it would be 5 significant figures if there were any decimal place up to it. What we should count is, although before this non-zero, after the decimal place or before the decimal places, the non-zero we do not count, but the trailing zeros after these decimal places should be counted. This is a significant figure, right? So in this case, this is significant figures. In this case, three significant figures. There's two significant figures. There is four significant figures in this case. And we do not count the exact number for infinite, that is the infinite significant figures, like pi value 3.141592. We do not count 1 or 1 dozen or like that. We don't need to count, right? The exact number, unit conversion factor, we do in the significant figure counting. We can count up to 3 or 4. It's according to your calculation needed. We will talk later on much about it. So this is the rules for significant figures and counting the significant figures. And I did not make the rule. So anyway, so this is an example that I'll go through very soon. Quick, what are the significant figures for number 1? Number A is 3, right? These are 3 significant. Yeah. His 3 significant figure here. This is 3 significant figure here, and for these significant figures here, there will be 2 significant figures because we do not count the 0 before the non-significant, significant figures, even before or with or without the decimal places. Here there are 4 significant figures. Here there is only 1 significant figure. Okay. Rounding up or rounding down these the figures. When this there is a value that is more than 5 before the value that we need to round up or round down. If it is more than 5, then we will round it up to the next value, right? So it's 4.327. So it is 4.33. It is rounded up to the next round figure. Like we need to express this number or value to 3 significant figures, right? We express this to 3 significant figure as well. We need to express this to 3 significant figure as well. So what will happen is we will round this. We will not round this up because the 4, even though 9 is here more than 5, but the 4 is less than 5. So this 2 does not get rounded up because the 4 is that, so it remains 16.2. But if I would make it 4 significant figure, I would make it 16.25, right? I would make it 16.25 because this is 9 is more than 5. But there's another rule that what we can round up and what we cannot round up. That is, the digit that need to be rounded up or down is odd, then it will go to the next round up. That means it will go to the rounded up. If it is even, it will not be rounded up. It will remain the same. So in this case, it will not be rounded up. It will be remain the same. But let's say that 16.239, right? If you're 16.239 and I want to express in 4 figures, so that it will be 16.24. It would be rounded up to 4, but since it is 4 is the even number, it is not rounded up. So this is the rule for rounding. Significant figures calculation. I mean, in the how to do you use this in the calculation? Addition and subtraction. That we add for is for subtraction. Addition, of course, we understand that we have to add up, but even for subtraction, the significant figures are always added. Okay, the significant figure will always be added, whether it's do the subtraction or multiplication or addition or division, whatever, it will be always added, and then it will follow the minimum decimal places. All right, it will follow the minimum decimal places. So like for this case, there are 1, 2, 3, 4, 5, 6 significant here, and here is 4 significant figures, but these are the decimal places. So what we do is we add these 2 up, right? We add these 2 up because this is 0.1 and this is 0.1 as well. So it rounded up to 0.2. I mean, sorry, it is added up to 0.2. And then what happens is we have to express this final value as 1 decimal places, because there are 4 decimal places here. There's 1 decimal places here. So the final value, the fewest decimal places that is used in this. So other cases, it would be what do you call it? Just 2, but it is rounded up to, because this is 9 here, so it is rounded up to 3. Even though you say that the previous slide we say that it is odd number, it does not round up, but in general practice is that we just everything. Okay, so the multiplication and the divisions, this thing, as I said, that significant figures will always find the fewest decimal places and minimum the significant figures. Here is 3 significant figure, here it is 4, 5 significant figures. So what we do is with the total value, we will express it as the 3 significant. Okay, total value we found it, we will express at the 3 significant figures, and it will be 16.5 for this case. There are some examples for you to try later on. I will put this up for on the module 1, week 1. So you must, I mean, every week, or not every week, 2-3 times, please go and check your module. There will be things, resources uploaded for you to check and do. go through this. You can just check and do if you want. Now, accuracy and precision. Okay, so what is okay, all these things you can go and check from the YouTube, these sites. Last time I checked, it was there. I didn't check this semester, but I hope it's still there on the YouTube. You can find this accuracy and precision, different type of error and accuracy and precision, uncertainty in the measurement, and all those things. All right, so accuracy and precision, if we if we express this through infographic in this way, like dart and the dartboard we throw, the first one, let's say this is number 1, this is number 2, and this is number 3 dartboard. So for number 1 dartboard, this is the bullseye, right? The red is the bullseye. The red is the bullseye everywhere. All my darts I threw to it, and then it was on the 1 point, very close to 1 point, but it is missing the bullseye. It is missing it. For number 2, my darts are not in the same place, are not close to each other, but it is all of them very close to this bullseye. But number 3 is all of them very close, and all of them very close, I mean, almost into that bullseye. So what is the difference between these 3? Here in number 1 board, that I threw all these darts, and it hit and it stuck to that 1 point, is is a very high precision. That means it is missing the true value. Let's consider this bullseye a true value, right? We want to find the value through our experiment, and the true value is the bullseye. This is the right? This is the correct value. But the problem is we missed this correct value, and all my darts go to the 1 place, even though it misses, my darts miss the true value, but all of them are in 1 place. So that means you have to give me the credit that I can throw the dirt very nicely, and I have the ability to hit it at 1 position, all 5 darts. That means that dirt, my accuracy is very low. Okay, so in this case, number 1 is high precision but low accuracy. My results are not accurate, but all the tests run I did, it is very close to each other. That means it is highly precise. I have done all the experiment is in high precision. That means I follow all accordingly, and there are some error occurred. I will come to that point, what are the error occurred. But there are some error occurred, but when the error occurred, all the error occurs, equally for all my tests run. If we consider all these 5 darts as 1 test, each individual test, like 5 tests I have done, I have missed the accurate point, but my precision is very high. Okay, and for the second one, you see that even though the 5 darts are not close to each other, but all of them almost found the true value or accurate result. That means it's high accuracy but low precision. The precision is not very high because probably the error occur, different type of error occur, and the methods that I followed to do that experiment, all 5 of these tests run I followed, and different error occur there. I was not consistent in the error that occurred in it, in the experiment methodology, but I have done it in a way that is almost found the true value, exact value for it. And for the third one, of course, there is no question. It is very good. Everything is very good. So there is no question. There's very less error, almost no error occur. Of course, there is some error occur, but almost insignificant error occurred there. So what does this tree tells us? Of course, tree is ideal case. It is very rare, and it's ideal case. We are not talking about it, but let's talk about this 1 and 2. So 1 and 2 is, even though you are, sometimes students, what they do is that they will just make the result up and try to find the accurate result. It is wrong, because if I have this type of and I can do some research, and what is the problem? Actually, is it the actual value that I know is something that is not true? Or what is the error occurring? And if that error occurring here, how can I be so consistent and making all the same error in all 5 experiments? So we can, I mean, this type of high precision, low accuracy even can lead to some nice nice result and some groundbreaking result. So students sometimes try to force the result, and they have to make it very accurate and very precise like this. And in real case, this type of things is very rare. All right, it's very rare. It doesn't always occur. These two things are very, common. These two types. So there are 2 types of error occur: systematic error and random error. Systematic error is that is consistent. This is beyond. It is maybe the voltage up down that we are using, the electric balance, the voltage up down. It is maybe the thermometer that we are using. It is not calibrated. It is making the same type of mistake for every run. It is maybe the the glassware that we are using. It is not calibrated, so it's making the same mistake for every trial run we are making. So this is the system. And a random error here is maybe it is due to our fault. We are doing it in a different way. Maybe we are different, what do you call it? Balance, different glassware, different thermometer at different run. We are not using the same thermometer, same glassware, same balance, electronic balance for all the different runs. So that is why it is making the big random mistakes. Okay, so what does error means? Error means that the difference between the true values and the experimental value and their ratios with the true value, the difference. Okay, the difference between the true value and the true values and the percentage. So this is that the percent of error. The percent of error is in this way. So the vertical line here, all right, the vertical line is telling the mole period. So even if it is any of this is, there cannot be any negative value. It always be, even if the experimental value is bigger than the true value, so it is supposed to be negative, right? It is supposed to be negative x. But since the mole is here on the both showing by this mole line, it shows that we will not consider this negative value, negative sign. We will consider everything is the same, I mean, positive value. Okay, so this is the true value for heat. And I think I will stop here today. Do you have any questions so far? How do we stop? Okay, you guys are still there. Any question, anyone? No question. All good. Okay. Thank you for your reply. But the thing is, next time I will not. I think you have this now. Will start another 2 minutes. But let me tell you that I will. The rest of the slides for the measurement or significant figures and then error and all those things, I will not go through. I will start the atoms because that is more important for us. And the rest of the thing I will, if needed, then I will discuss during the lab, next lab. And from the next class, actually, it will, I mean, I want you to engage in the discussion, if ask question or share your point of view or something like that. So it will be much engaging. Otherwise, I'm just talking alone and it's not very good for me as well. Okay, so I hope you have a good, nice day ahead. If you have any question, please send me an email and I'll see you tomorrow 1 p.m. Okay, all the best. And this video will be uploaded to Canvas soon. Thank you and have a nice day.